Thank you very much, and I'm delighted to be here as well. Delighted to see you all together. I hope we're going to keep the energy going on this screen at the moment. I'm not going to touch anything in case it goes again. But this is a very important topic that everyone around the world is concerned about: energy. And I'll explain a little bit about why. First, I want to introduce you to George. Now, George is a new undergraduate who started at the University of Manchester this year. Here you can see him walking along the university campus, surrounded by other students. Well, he came to university this morning on the metro. Last night he was cooking pasta bake with his girlfriend. His dad, at the moment, he looks a bit thoughtful at the moment. Well, his dad's in hospital, as you can see there, being treated for a heart attack. And he's got to remember to email his gran, because she's one of these silver surfers who use the internet a lot. Of course, you know what I'm going to say. What's common to all of these things, and as you've already heard, what's common to all of our lives, and that is energy. And we all need energy. Now, the world actually is going through a bit of an energy crisis. And there are really two reasons for that. So let me just show you a graph. This graph shows the growth in the world population since about 1700 up until the present day, and then predicted out into the future. Now, what you can see from this graph is way back in 1800, there were 1 billion people around the world. In the year I was born, there were 3 billion people in the world. Now, something has happened since then, and you can see that the number of people has grown hugely year by year, so that in about 10 years' time, there will be an increase of a further 1 billion people by 2024. When you're in your mid-20s, a further 1 billion people in the world. And you look forward a little bit more, and there will be even more people. And that growth is not dominated by growth in the UK or in America. It's dominated by growth in Asia and Africa. Now, let's just think, what does 1 billion people look like? Well, here's our wonderful city of Manchester. The population is about 500,000. So if we think another billion people in about 10 years, what does that mean in terms of the size of Manchester? Well, actually, it means there are going to be round about another 2,000 cities around the world about the size of Manchester. That's where people will tend to congregate, in those cities. And those cities are going to need electricity. And if we don't provide electricity, then the quality of life of the people that are going to come after us are going to be pretty poor. So here's just an example. This is a place I've driven past, Kailesha, just outside Cape Town. You can see over 5.5 million people live in this sort of squatters' camp. And one of the drives is to provide electricity to this growing population around the world. A guy who used to lead Eskom, the electricity provider in South Africa, a guy called Ian McCray, this is what he said, and this was his vision when he led the electricity generating capacity of that country. And he said the best way to combat poverty and is to provide economic growth and social uplift. And the key to this is the availability of usable, efficient, and affordable energy. And so that's the challenge we face today. So if we look, we've seen the population growth. What's going to happen to the electricity needs around the world? Well, here's another bar chart this time, which just illustrates what is going to happen around the world in terms of electricity generation. What you can see, a lot of the developed countries in blue, they're not going to need that much more power because we're going to become more efficient in our use of electricity and so on. But in Asia and Africa and these developing nations, they're really going to need a lot more electricity. And you can see that, again, in 2025, in just over 10 years' time, there'll be a 30% increase in electricity needs. And by 2035, it'll be 50% increase. So all of the predictions going forward is this world's going to be a busier place, there are going to be a lot more people around here, they're going to need a lot more electricity, and we're going to have to provide it in some way. Otherwise, people are going to be living in those shanty towns, and that's not what we want. So you think, well, that's fairly straightforward. We're just going to build a load more power stations, build some windmills, and everything will be fine. Well, the big challenge actually is a lot of our big power and a lot of our electricity pumps out carbon dioxide into the atmosphere. And you will all have heard of global warming. You will all be reading about it for your GCSEs and understanding something about it. And it is a real challenge to this world. How do we balance the increase in the amount of energy that we're going to need as a planet with handling global warming? And really what that means is that we have to really take global warming seriously. So this graph just shows something about the temperature rise associated with carbon dioxide in the atmosphere. And you can see the increase in carbon dioxide leads to an increase in the temperature. And you think, well, that'd be rather nice, living in Manchester, a slightly warmer, less wet climate, we quite like that. But actually, for a lot of places around the world, this will have massive, massive consequences. It's predicted by the end of this century, we're already locked into a 3 or 4 degree increase in global temperatures. That means that the sea levels are going to rise. All those populations living on the coasts are going to be displaced. There'll be an increase in sickness, in poverty, and so on and so forth. And so one of the greatest challenges for the planet is how do we provide electricity to this growing population and manage the carbon dioxide we're pumping out into the atmosphere. So every country around the world has an energy policy. They look forward and they think, where is our energy going to come from? We've got one in the UK, and I've shown another one there, which is for Singapore. And when you look at all of these energy policies, with governments thinking hard about how are we going to provide this electricity, actually, they're common. There are 4 principles that every energy policy is built on. And this is what they are. Firstly, we really have to maximize the energy we get from low carbon sources. Secondly, that energy has to be affordable. Nobody wants their electricity bills to go up, so we've got to keep the prices down. The energy has to be secure. We don't want power cuts. We don't want to be dependent on other countries for our electricity. We want to be secure so that we can, when we flick the switch on, we know the lights are going to come on. And we need to be efficient in the way we use our electricity. So we use low energy light bulbs. We turn the lights off when we go out of the room, and all of this sort of thing that can make a difference. But there are these 4 principles about electricity in the world. Every country is looking at it, and every country will have its own mix of energy. When you look around the world, this is last year where the electricity came from. And you can see the red is the combustible fuels. That's the fuel that is generating carbon dioxide out into the world. You can see that hydro, water power, accounts for 14%, quite a big block. Wind and solar and geothermal and other energy sources account for 4%. But nuclear energy actually accounts for about 1/5 of the electricity around the world. And in this country, it's round about 15% at the moment. So it's an important slice. But the important thing to bear in mind with that chart is that the red means carbon dioxide is going out into the atmosphere. It means that we're helping global warming, the planet temperature to rise. Everything else is low carbon. And so what we need to do going forward is to reduce the amount of red that's on that pie chart and increase the amount of green, blue, and orange. So again, people have looked forward and said, well, where is our electricity coming from at the moment? And here you can see that in terms of historical terms, where's the electricity come from? You can see all the trends are upwards because we need more electricity for reasons I've already discussed. But what's going to happen in the future? Okay, well, this is what's predicted. Energy from every single source will increase. Countries will continue to build coal-fired power stations, gas-fired power stations, nuclear power stations, then increased wind farms, then increased solar energy and wind and all the rest of it. Renewables, that's energy from wind, from solar, from waves and so on, will increase at least 3 times. And again, in this country, as you will have seen in the news, we're looking to increase the amount we get, particularly from offshore wind farms. Nuclear power will double. That's the prediction of the experts, the International Energy Outlook Agency. But actually, you can have a look yourself to see how you would manage energy going forward, particularly in the UK. There's a website that you can log on to, and you can run this like a game and work out what energy mix can the UK have, because the UK has signed up to reduce the amount of carbon dioxide we pump out into the atmosphere by 80% by 2050. And it's a real challenge to think, how on earth are we going to do that? Well, here you can see on the left-hand side of the slide at the bottom, where does our energy come from? And as you can see, a lot is from oil and gas, a little bit is from nuclear, and very small amounts from other sources. So you can play about with where does our energy come from, but you can also, on the other side, play about with how do we use our electricity? How can we become more efficient? How do we travel? How hot do we heat our homes? And all those sorts of things. So I had a bit of a go at this to try and reduce this CO2 level all the way down to 20%. And this is what I came out with. So I increased, for example, how we travel. We currently use petrol or diesel in our cars. Well, if we used electricity, that makes a big difference on the CO2 emissions. So you can play around with all of these things. That was one thing I thought would be a practical thing to do going forward. I also looked at the supply side. And what I did was I reduced the amount of energy from CO2 emissions methods, and I increased the amount of energy from low carbon methods. As you can see, nuclear power I increased, wind turbines I increased, and solar, marine and hydro power I tried to increase as well. And you can see you can do it, but it means an increase in low carbon energy sources and a decrease in things like coal and gas and that sort of thing, which pump CO2 into the atmosphere. So that's the challenge that we face as a planet. So let me just give you some key messages from that first part. Firstly, the population is increasing around the world. If we're going to keep that population out of poverty, we have to provide electricity to them. But we have to do it in a way where CO2 emissions come down. Energy from all sources we need to use, and every country will work out its own energy mix, just as we have done in the UK. And actually, probably all sources will increase. Renewable energy will at least triple. Some countries are trying to really dominate their energy policy with renewable energy. Nuclear energy is certainly going to double. And you're likely to be driving these cars in 10 or 15 years' time.